So how do we go about fitting a new piston to a 1988 Cagiva WMX250 with an iron liner? Well, after much searching, it became clear that there is no piston made to fit this bike. The 1988 should have a Nickersill bore, for which there are Vertex pistons available. But this bore size is 0.5 mil bigger than the standard Nickersill bore. So, after much searching, the closest piston I could find is this Wiseco, which is designed to fit an earlier Husky motor. But there are differences. There are some windows in the piston which will provide an opening to the boost port when the piston is at top dead centre. So this will allow a little bit of extra charge into the bottom end. So that's all good. Then the skirt is slightly longer. I thought I would need to trim the bottom of the skirt to make sure that it wouldn't contact the crank. But it's miles off, so no trimming required. The piston crown is also taller, so again, we may need to machine some of the crown away. But first, and this is the big thing, we need to check the port timings with the standard thickness base gasket and the original piston. To do this, I'm going to use a degree wheel. I'm going to set the piston to the top of the ports I want to measure. So in this case, it is the exhaust port and the transfer ports. Then I'm going to set my degree wheel to 0 and set a pointer up so I can see where it ends up. Now I rotate the engine so the piston travels downwards, opening the port, and back up until the port is closed again. Now take the reading off the degree wheel, and this is the port timing with the standard piston and the base gasket. Now we need to measure with the different piston. In this case, the piston crown is taller, so I'm going to use a thicker base gasket, which is going to total about 1 millimeter. And then we remeasure, doing exactly the same thing again. Once measured, I was really happy because the port timings have come out within a couple of degrees of each other. So we're going to leave this exactly as it is. It's going to make very little difference. The next thing is the head and setting the squish. The head I was sent with this bike was damaged. It had something rattling around in there at some point in time. So we need to take some material off the head. This will mean we can clean it up from the damage, and we can also get the clearance between the piston crown and the head to be in spec. This is called the squish band, and on a 250 it should be set to between 1.2 and 1.5 millimeters. This will also mean in future that the owner can just buy a new piston and install it, rather than having to have the piston machined each time he wants to change it. So I had a few issues setting this up, as the spark plug hole must be very slightly off centre, so I couldn't get it to rotate true. I'd been holding it in the lathe using a tool I've made that threads in by the spark plug hole. So if it won't rotate true using that, then I'll need to mount it using the faceplate for the lathe. I set that up using some adjusting nuts so I can set the head to run perfectly flat. I can basically adjust it in and out in 4 different axes. Now that's in place, I've cut all of the damaged area out and cut a new squish band in, matching the profile of the piston crown, and it looks really good. And after a couple of checks, we've got the clearance gap we were looking for of 1.35 mil. I measure the squish clearance using plasticine or modelling clay, and I like the bright colour as it makes cleanup of any debris easier. This bike should run great now and can have future piston changes without the problem of finding a piston to fit or having to machine one down. Lovely job. Thanks for watching, and don't forget to follow me or subscribe to my channel. Have a great day, two-stroke fans.